Okay, in this video we're going to cover Chapter 9 of the curriculum, which is regarding multi-area OSPF. So in Chapter 8 we talked about where you had a single OSPF area. Chapter 9 we're going to talk about dividing that into multiple areas, as the name implies. So that's the whole purpose of multi-area OSPF, is to use it to divide a larger OSPF network into smaller sections. As often, the chapter starts with a class activity. This one is called Leaving on a Jet Plane. I am going to assign that, so watch for that to appear in Blackboard. So in the case of single area OSPF, which we're seeing a picture here, we're going to have larger routing tables because all the routers are in one area. We're going to have a larger link state database because there's more link states that we need to track within our network. And anytime there's a topology change, we're going to have a number of SPF algorithm calculations. So the purpose of multi-area OSPF is to alleviate some of those issues. So here we have a topology that's been divided into three areas. Area 0 is our backbone area. Typically there are no user devices in area 0. And then here we have an area 1 and an area 51. And what happens is the link state advertisements, for example, for router 1 is only going to come from 2 of the 3 areas, the 2 areas that are attached to that router. Any router, in this case router 2 is shown, is only going to need to run the SPF algorithm when there is a change in an area associated with, in this case, area 0 or area 51. And then, as shown by the router in the bottom left, the routing table is going to be smaller because it's only going to exist for or contain information about routes in that area and the default gateway to make it to, in this case, router 1. Here they're showing that the link state addresses they showed for router 1 before, in this case router 2, is only going to receive it from the 2 areas that it's connected to. Okay, here in figure 1, a couple things they want to point out is that there's a backbone area that's highlighted and shown in yellow. Again, there are no end users in the backbone area. It is always area 0, and we're going to have fast and efficient movement of IP packets because of the reduced overhead. Looking at this, they're talking about the non-backbone areas, which in this case would be area 1 and area 51. Okay, as far as the different types of routers, they're shown over here on the right. The first is internal routers, and this is a router that has all of its interface in the same area. So highlighted here, to here, and here are the internal routers. Another type of router that we talk about is a backbone router, and this is a router that is in the backbone area. So here we have 4 that are in area 0. Area border router is a router that is on the border of an OSPF area, so in this case router 1 and router 2. And then finally we have an autonomous system border router, an ASBR, and that is going to be one that is connected to an external network connection, in this case the internet. 9115 is an activity to make sure you understand the terminology we just talked about. There are 2 different activities, or 2 different figures here, so you can go through and do these on your own when you're ready. This 9121 starts talking about link state advertisements, and it tells you the different types. Some of these will be discussed later down, but we have the type number that's going to appear in the packet, and then it tells what type of link state advertisement it is. Okay, link state advertisement type number 1. That link state advertisement is going to contain link state information for a list of directly connected network prefixes and link types, so basically networks associated with it. All routers are going to generate type 1 advertisements. Type 1 advertisements are flooded within the area, and they do not propagate past a border router. And the link state ID is identified by the router ID of the router from which the link state advertisement came from or originated at. Type 2, identify routers and network addresses of multi-access links. So what happens is it's going to, in this case, propagate from this router to this router to this router. Only designated routers generate a type 2 link state advertisement. They are flooded within the multi-access network and do not go beyond the boundary of an ABR. The identification of the link state advertisement is the designated router ID. A type 3 link state advertisement describes network addresses learned from the type 1 link state advertisements. Type 3 is required for every subnet, so here we can see that the routers are sending those into each of the subnets or each of the areas. It is identified by the network address, so in this case not the designated router. And by default, routes are not summarized. If you want them to be summarized, you have to indicate that to iOS. This shows a Type 4 advertisement. Type 4 advertisements are used to advertise the ASBRs to other areas. So we can see here that this router is advertising into area 0. This one's advertising into area 2. They're generated by an originating ABR, and they are regenerated and retransmitted by other ABRs in the topology. It is identified back again by the router ID of the ASBR that originated the message. And then I think the last one we talk about is a Type 5 link state advertisement. These are used to advertise external network addresses. So in this case, it would be coming with information about our internet connection. They're flooded through the area, and then other ABRs, as we see here, regenerate those, transmit them into their area. Here's another ABR that's going to see that and retransmit it, in this case to area 2. Again, the link state ID is the external network address, and by default, like Type 4, Type 5 link state advertisements are not summarized unless you tell them to be. 9127 is 3 different activities related to how different, shown on the message is being sent, what type link state advertisement you have. So there are 3 different activities here with 3 different types of link state advertisements that once you study the previous sections, you can go through and do on your own when you're ready to. 9131 is showing us routing table entries. So show IP route is the way we get routing tables. And here they have highlighted the different routers, the networks, how you get to them, etc. So it's showing the router information. And then here, show IP version 6 route is showing us the same information for the IP version 6 configuration of the routers. Okay, as far as route calculation, there are three things here. The ones that are labeled with the one with a circle around those are the best path to destinations that are located within the same area as the router, in this case, router 1. The route shown here with, well, there's actually two that are shown with the number 2. This is the best path to other areas within the network. And then finally, up here at the top, labeled with the 3, this is the best path to external autonomous system designations. So, in this case, it's the default route and tells you how to, what IP address to go to out which interface. So that's kind of the things they wanted to highlight in this figure. This is an activity to make sure you understand the order of OSPF best path calculations. So you can do that on your own. (9211) and some of the following sections are going to talk about implementing multi-area OSPF. So what we have to do is we have to gather information about the network. We have to define the OSPF parameters. We have to configure OSPF. And then once we configure it, we should verify that it is working correctly. So the following sections are going to talk about that. So in this figure, we have the topology that we're going to be using. Notice we have a backbone area, and then area 1 and area 2, so 3 different areas. The next figure is showing us how this would be configured with a router ID, and then what networks and what area those networks are in. And then 3 is a do it on your own. Can you replicate the various things that were configured in the previous graphic? (9213) is showing us kind of the same topology, but in this case it is addressed with IP version 6 IP addresses. These are the commands that we would use to go through and configure those OSPF areas and a router ID. And then, as kind of has become the habit, the last figure is the can you go back and replicate the steps that we just talked about. Once you've configured OSPF, like you said, you should go through and verify that everything is set up and working correctly. In this case, they show you the commands over here. For each router, you want to get on and you want to check the neighbor, the link adjacencies. Then you want to look at the OSPF configuration. Then you want to look at the settings for the interface that's running OSPF. And then you will want to look at what protocols are running, get a brief listing of the interfaces to make sure they're configured correctly. You want to do a show IP route to make sure the routing table looks correct. And then you may want to look at the OSPF database to make sure that it looks like it is populated correctly with the topology. So here is the show IP protocols. Notice that there are routing for networks that are in various areas. Tells you how many areas are serviced by this router, and then it gives you information about the routers that are in the topology that it knows about. Here, Show IP OSPF Interfaces Brief is showing us all the interfaces and telling us what network and what area, more importantly since we're talking about OSPF, that these are in. And then finally, go back and issue those commands yourself to make sure you understand how that works. 9223 is verifying the routes. So we start out with Show IP Route OSPF, and we see the routes here. We see information about it. We see cost about it. We see what interface you would need to go out to reach those networks. And then this is do it yourself. This is looking at the database, the link state database to be exact, and it's showing us link IDs and router information and that type of thing. So it's basically telling us all the information it knows about the link state database, which should be for all the routers in the topology. And then the second one is, can you do that on your own? 9225 is talking about verifying, verifying for IP version 6. So we have the topology shown with IP version 6 IP addresses. Just like before, instead of show IP protocols, it's show IP version 6 protocols. We get all the same information, the areas, the interfaces, what interface on the router it's on. Show IP version 6 OSPF will show us the interfaces and what area they're in, so we can make sure that's correct. And here we show the routing table, so we can verify that our routing table is correct. And then finally, we look at the database for IP version 6. So it's going to look very similar to what we had before, except the IP addresses are going to be IP version 6 addresses. 9226 is a packet tracer on configuring multi-area OSPF version 2. So they'll be working with IP version 4 addresses. I will probably be assigning that, so look for that to appear in Blackboard. (9227) is another packet tracer activity. In this case, it's related to OSPF version 3. Therefore, it will be talking about IP version 6 addresses. In my opinion, this is exactly the same, except the IP addresses may be a little harder to type because they're a little longer. So I will not be assigning this packet tracer. Next, we have a lab. This is basically the same as the packet tracer activity I've already assigned. So I will not be assigning this lab. Same thing here, except for OSPF version 3. This is the same as the packet tracer that I told you we wouldn't be doing. However, it's similar to the OSPF version 2 packet tracer that you are doing. So I don't see any need in having you do basically the same thing 4 different times. This finishes up with a class activity called Digital Trolleys. I read over this and I didn't see a whole lot of benefit in actually assigning it, but it's just like a page and a half long. So you should read through it just to kind of see what they were going to have you do and what they're trying to get at. And with that, it takes us to the summary for Chapter 9. So watch for Chapter 9 from netacad.com to be assigned and announced in Blackboard.